Hello, welcome back. We are going to discuss about the first algorithm strategy, divide and conquer, in this session. So, what is divide and conquer strategy? As the name indicates, given a bigger problem or a complex problem, we divide the problem into smaller subproblems, find the solution to each subproblem, and merge to get the solution to the original problem. So that is divide and conquer. Dividing the bigger problem or dividing the biggest problem into smaller subproblems, find the solutions and merge to get the solution to the original one. So there are so many algorithms based on this divide and conquer strategy. So if you look at the definition, so a divide and conquer breaks a problem into subproblems that are similar to the original problem, recursively solves the subproblems, and finally combines the solutions to the subproblems to solve the original problem. So the control abstraction, actually the control abstraction is an abstraction of the steps of divide and conquer. So it's the process by which programmers define new control constructs, specifying a statement ordering separately from an implementation of that ordering. So to be specific, control abstraction means a procedure whose flow of control is clear but whose implementation are the primary operations necessary to implement the function are not specified explicitly. So let us write the control abstraction for the divide and conquer. So these are the functions used: small of p, a boolean valid function that determines whether the input size is small enough that the answer is computed without splitting. Combine is a function that determines solution to p by combining the solutions of k subproblems. So we are dividing the given problem p into k subproblems, find the solution to k subproblems, and at last merge. So control abstraction for divide and conquer algorithm DNC. P represents the given problem. So if small of p, then return s of p. So this statement means if the problem is small enough to find a direct solution, then return the solution. Otherwise, divide the problem into smaller instances, p1, p2 up to pk. Apply divide and conquer to each of these subproblems. Return the solution after combining the solutions to all the subproblems. So combine, divide and conquer. So DNC of P1 returns the solution to P1, DNC of P2 returns the solution to P2. Likewise, we combine the solution, we combine k subsolutions to find the solution to the original problem P. So this is the general control abstraction for any divide and conquer based algorithm. So binary search is the best example where you can apply divide and conquer strategy. So what is binary search? So binary search is a process. We search for an element. So searching is the primary objective for using binary search. So how do we implement binary search? So binary search algorithm requires the given set of elements to be sorted. So that is the major basic requirement for applying binary search. The input array of elements should be sorted. So the given array is divided into two equal subsets. The search element is compared with the middle element. If the match is found, then the location of the middle element is returned. Otherwise, we repeat the same procedure, that is divide and conquer. Again, we divide the array into two subarrays. So if the middle element, if the search element is greater than the mid element, then we leave the first half, we focus on the second half. The second half is further divided into two subsets, and then we apply the same procedure. We repeat the same procedure. Suppose if the search element is less than the mid element, then the search area will be refined to the first half. We will be searching the first half of the array. we repeat the same process and find the search element. So binary search works only on a sorted set of elements. So this is an example. Here we have an array of 10 elements. Let us assume we are looking for the element 17. So here there's 10 elements. The mid element is the fifth element. We compare 17 with 11. So 17 is greater than 11. So we just eliminate the first half. Now the search is focused only on the second half of the array. So find the mid element of the second half. So the mid element is 19. So there are totally 5 elements. Mid element is 19. 17 is compared with 19. Now we find that 17 is greater than 19. So the search area narrows down to the first half. So 13 and 17. So here 13 is the mid element. We compare with 17 with 13. There is no match. So as 17 is greater than 13, we focus on the remaining element 17. Finally, we are able to locate the search element. So this is how binary search works. So given a set of elements, we compare the search element with the middle element. If the middle element is greater than the search element, then the search area will be the first half. Otherwise, the procedure will be repeated for the second half. Now if you look at the algorithm, it will be recursive in nature. So binary search, we have the input parameters are A, I, L and X. So I and L specifies the lower and upper bound of the search array. X is the search element, A is the given array. So if L is equal to I, that means there is only one element. So it satisfies the small of P condition. If X is equal to A of I, then return I. Else return 0. So if L is equal to I means the problem instance is small enough to give a direct solution. So if the search element is equal to the element, then return I, otherwise return 0. Now if L is not equal to I, that means the problem is bigger. So there is more than one element. In that case, you need to reduce P into smaller subproblems. That is, you have to divide the array into, you have to proceed with either a lower half of the array or the upper half of the array. So compute the mid element. So I plus L by 2. If X is equal to A of mid, then we have found out the middle element. If there is a match with the middle element, we have found out the location. Else, if X is less than A of mid, that means the search element will be in the first half. So binary search is recursively applied to the first half. So the parameters is called with A, I is the first element. The last element in the first half will be mid minus 1 search element. Otherwise, the second half starts from mid plus 1. So mid plus 1 comma L. So I and L specifies the low and the upper range of the array of elements, search range. So earlier we saw we discussed the recursive binary search algorithm. The same algorithm can be implemented using iterative search. So in iterative search, we have two variables, low and high. While low is less than or equal to high, we compute the midpoint and compare the search element with the midpoint. If it is less, then high is set to mid minus 1. If X is greater than A of mid, then low is set to mid plus 1. So it will focus on the second half. Otherwise, return middle element. So both the algorithms implement the binary search using divide and conquer strategy. So for now, we have during this session we have discussed about the divide and conquer strategy, and also we have seen an example how we have discussed an algorithm where we apply the binary divide and conquer strategy, binary search. Binary search is one of the popular algorithms. So the primary requirement for implementing binary search is the given array should be sorted. So we discussed both the versions, iterative version and recursive version. So with this we shall discuss the remaining we shall see another example in the next session. Thank you.